Assalamualaikum to all the judges. The title of my research is a modification of pre-cut gauze coated with carboxymethylcellulose as a potential wound dressing with healing properties. As an introduction, gauze is used in wound management treatment due to its high capability to absorb exudate, but unfortunately, it leads to wound dehydration. With no healing benefits, gauze will get stuck at the wound bed, thus requiring frequent changing, and this condition is prone to bacterial infection. Dressing changing will provide discomfort and sometimes can cause secondary injury upon dressing removal, thus damaging newly developed tissue. In addition, CMC cross-link with citric acid will reduce the gauze hydrophilicity and ability to retain moisture, avoid wound dehydration, and thus minimize contamination. There are three main objectives of this study. The first is to study the effect of plasma treatment on the gauze morphological changes, surface roughness, zeta potential, and crystallinity index. The second is to investigate the effect of CMC coating on the pre-cut gauze by using citric acid as cross-linking agent. Lastly, to observe the formation of CMC film cross-link with citric acid on the pre-cut gauze that was coated by using a wet film applicator. Materials and methods. Gauze as the main precursor was undergone plasma treatment. These steps promotes functionalities, creating an etching effect, enhancing surface roughness, and changing the surface energy of the treated surfaces and coincide for adhesion of drug or bioactive compound. Then, 2% of CMC was dissolved and coated using a wet film applicator to control coating thickness and evenness. To promote adhesion and strength, CMC coated gauze was soaked in 2 molar citric acid and then dried in an oven at 40 degrees Celsius overnight. Results and discussions. SEM images show that higher exposure time to plasma treatment leads to the appearance of grooves, slits, and cracks. This showed that prolonged plasma bombardment of gauze surfaces causes etching and sputtering effects and leads to surface deterioration. The SEM images were supported by surface roughness analysis. As exposure time increases, surface roughness also increases. Higher surface roughness indicates a higher surface area, suggesting that coating adhesion is better, but the mechanical and the physical stability of the gauze is agitated. The zeta potential for the control sample is negative. Increasing exposure time causes the zeta potential to be more positive. However, at 30 minutes, the value returned to a negative value due to the surface degradation and plasma bombardment, removing the functional group of nitrogen. As for the crystallinity index, the results are proportionate to other analysis. The crystallinity increases up to 20-minute plasma exposure and decreases at 30 minutes. The decrement proof that the destruction not only happened in the amorphous regions but also in the crystalline area. From the images, CMC coated gauze is successfully attempted. Surface treatment and cross-linking effect by citric acid that help promote adhesion of CMC to gauze. Citric acid is not only used as a cross-linking agent but also to promote the antibacterial property of the CMC coated gauze. Modification of pre-cut gauze as a potential wound dressing was successfully prepared. The film was formed due to the cross-linking reaction between the CMC hydroxyl group with the carboxyl group of citric acid. Upon swelling, gauze CMC will form a thin film that can absorb liquid and maintain a moist environment, thus avoiding wound dehydration. According to Souza et al., the hydrated wound will accelerate angiogenesis, prevent cell death, and potentiate growth factors interaction with their target cells. The advantages of modified CMC gauze are good attachment, flexible features, and transparency. Each of these benefits when dressing applications. In conclusion, plasma treatment on the gauze surface did promote adhesion and functionalities to the pre-cut gauze. The CMC gauze film was formed due to the esterification cross-linking mechanism. The swelling ability of the film preceding the water absorption provides a moist environment during wound treatment. As for future development, the study will contribute to the continued development of wound dressings in the future. The standard wound dressing will have medicinal properties, the ability to function as a skin scaffold, and will effectively work as a smart healing device. In the course of this research, each of these will be put into action and evaluated. Thank you for listening and attention. Regards.